So welcome back students. Welcome to this YouTube channel of GatePro for daily dose of gate questions. Every day you'll have one gate question. We started this initiative with maths. We'll extend this for electrical, electronics and every subject. So daily dose of gate questions. So today 23rd April question number 8 starts from vector calculus. So look at the question. The line integral of the vector A, where A is gradient of a scalar G, where the scalar function G is x into e power y plus sin z. So you have to find out the line integral of a vector which is obtained from gradient of a scalar. So scalar G is gradient you have to take, and you have to find the line integral from 0 pi by 4 to 1 pi. I hope the question is very clear. So gradient and the vector that you get from gradient, you have to find the line integral. First of all, what is gradient formula? Gradient is nothing but x derivative in the x direction, y derivative in the y direction, z derivative in the z direction. So gradient gives you a vector. That vector is what is A vector is. So gradient gives you a vector and that vector is A. So what is gradient going to give you? Dou by dou x of G, dou by dou y of G, and dou by dou z of the G, where G is x power y plus sin z. So that should give you e power y ax plus x into e power y ay plus cos z, as you see the derivative. So e power y ax plus x into e power y ay plus cos z. Now here comes the bottleneck. After this, we don't know the line integral path because the question has nowhere given any path. So gradient you can find out no doubt, but the vector A you can find out no doubt, but you don't know the path. So what is the methodology of evaluating it? Obviously, a gate question which is supposed to be simple in nature, or at least something which should give you a very quick answer, cannot take so long. So if you look at what and how you have to handle it, what are they asking you? They're asking you the line integral of del G dot dl. They're asking you gradient of dl, gradient of G and then dl. So grad G, which is A dot dl. So what is grad G? Dou G by dou x. And you're asking you to find dot dl. That means again you integrate with dx. So gradient operation is nothing but derivative operation. Gradient operation is derivative operation, and you're finding out integration of dx. Dou G by dou y integration of dy. So what should this give you? X and x integration derivative cancels. Integration derivative cancels. It's nothing but integral of dou G. So it's nothing but G with the limits applied. So when you're asked to find gradient or derivative and then integration, it is nothing but the scalar's upper limit and lower limit. So apply your scalar's upper limit at 1 pi. 1 pi sin pi 0. So 1 apply it at the lower limit 0 pi by 4. 0 pi by 4. So upper limit gives you E when you apply for this G value. Lower limit gives you 1 by root 2. So the question looks to be complicated. The question seems as if you have to find the gradient and you have to find the vector. But the gradient operation is not needed here. Because even after gradient operation, what you have to do is integration with again distance. Integration with the length. So differentiation and integration, two contrasting operations cancel. And it is just about nothing but G applying the upper and lower limits. So G's upper limit at 1 pi, G's lower limit at 0 pi by 4 should give you 1 into e power 1 into sin pi plus sin pi 0. So it's E minus the lower limit sin pi by 4, that should be 1 by root 2. So the answer is E minus 1 by root 2. So these sort of questions are very logic oriented, students. These sort of questions are what you have to handle in GATE exam. It should make you think. Every day we'll come out with such questions. So do like, subscribe our channel and do follow us for such interesting questions in every topic will come out. Probability we have finished, so do watch them again. We are going with vector calculus now. We'll come out with all the subjects in electrical and electronics. this daily dose will continue, students. So do share, do inform your friends that we have such a noble initiative. And see you, students, tomorrow with one more question on 24th April, question number 9. Goodbye.